So we'll start out with the mistake I made. On the review, there was supposed to be a picture with number 1. So at least one of you was like, wait a minute, how am I supposed to find the min and the max when there's nothing there? Like, yeah, that's a mistake on my part. So the picture was supposed to look, I forget what it was supposed to look like, something like that. So let's say that's A, that's B, and that's C. So let's just do this one together real quick here. So where is there a relative max? Nowhere. Why nowhere? You're right. You don't want to call it the max, but the highest part. That's a good way to say it. The biggest value is right in there somewhere, but you can't pin down what the biggest value is because it's an open circle. So if that open circle's at 10, well, we never get to 10, right? So you can't say the max is at 10 or almost 10. You could make a limit statement, but there is no maximum there.
Wait, but aren't they in brackets?
On A to B. You know what? I could have done this. Yes, they are in brackets. So let's do it. Let's do it this way then. See what I did there? Now what's the relative max? 10. And where is the relative max? At x equals b. Good catch. And you see what I did there. How about the relative min? That doesn't exist because it never gets to 1. Right? One is beneath all of those values. Like, well, it gets to 1.000001, but you can't ever specify its lowest value. So there is no relative min. So be careful on the open circle, closed circle stuff, especially for maxes and mins. And I inadvertently showed you kind of the two ways you could do it. You could put them at the end, or you could put them in the middle. But if there's a max or a min at an open circle, then the max or the min doesn't exist. Maybe that's the easiest way to say it.
Wait, so sorry, was it just in the picture that you didn't include? Where did you get the open circle?
Because the graph would have been provided.
Okay.
Yeah.
I thought we had to solve for the absolute maximum.
Find x values of the absolute min and max. Well, the x value, so the answer, the absolute min is none, the absolute max, the x value is b.
Oh. I was just confused because we wrote relative and relative.
I sure did. I should have put absolute. I mean, they were still both correct, but it asked for absolute.
Okay. So all relative max and mins, all absolute max and mins are relative as well?
Not necessarily, because if it occurs at an endpoint, that's not a relative max.
Okay. So the absolute is when it's at intercept.
So an absolute might come from an endpoint, but it might come from not an endpoint, a critical point.
Okay.
All relatives, though, will come from, those will not be at endpoints, because they can't be an endpoint, because you can't be higher than your neighbors if you don't have neighbors.
Yeah.
So all relative come from critical points,
Okay.
but not all critical points are extreme. Anything else on the review? And then I'll do questions from the other one. Anything else from this one? Number 2, sketch a graph where? Let's see. F prime is greater than 0 except at 0. So what does that mean about f? If f prime is greater than 0, what does that mean? F is increasing. So f is increasing everywhere except 0. Oh, and here we go. F prime of 0 equals 0. So what's going on at 0? It's a critical point. What does it look like on the graph? You're right, it is a critical point. It's a horizontal tangent line there. So I need to increase, but I got one flat spot, and then I'm increasing after that. So we're increasing the whole way except at 0 where it's flat. All right, when x is greater than 0, second derivative is positive, so that's concave up. When x is greater than 0, so I'm going to kind of label my graph here. So concave up that way. Concave down when x is less than 0. And then f of 0 equals 2. So the point 0, 2 is on my graph. All right, so at 0 there's a little bit of a flat spot, just briefly because it's positive everywhere else. So we're increasing the whole way, but on this side we're concave up. So I need to be increasing and concave up. That's what we just drew, something that's increasing and concave up. On the other side, I still need to be increasing, but I need to be concave down. So something like that. So now I've got a graph that meets all of those criteria. And that graph might look a little different depending on how you drew it. Everybody should have 0, 2, but you could have it like a little steeper like that. That would still be correct. Other questions on the review? Should probably focus on the review because that's a test-inspired review. Number 3, find the absolute min and max. So absolute min and max. So I'm thinking already critical points, but the only way to find absolute min and max is the top path. That's the table of values. So I need some critical points to put on my table. I also need endpoints. Although what is going on, I need to be real careful here. Right, so something's going on at 0. That's an open circle there. So I want to test it, but if that's the maximum, then I don't have a maximum, right? That's the open circle thing. If it's the minimum, then I don't really have a minimum because of the 0 there. All right, let's simplify first. X squared plus 4x plus 5. Then I can take a derivative. Oh, now I know why we can't include 0, because I got an x in the bottom. That's why we're not including 0. 2x plus 4. So I set that equal to 0. So x equals negative 2 is my only critical point. So this isn't too bad. Now I just need to plug them in. I'm going to plug them into the simplified version. Again, something is going on at 0, but I need to figure out what's going on at 0. All right, if I plug in negative 3, I get 9 minus 12 plus 5. That would be 2. If I plug in negative 2, I get 4 minus 8 plus 5. That would be 1. And if I plug in 0, I get 5. Yes, sir.
Why did you only take the derivative of the top part of the fraction? Don't you have to do quotient?
I simplified first. This is f of x. I did algebra first to avoid the quotient rule. So what is my absolute minimum? Not where is it, but what is it? What's the absolute minimum? What's the lowest value? The lowest y value? 1. And where does that happen? At x equals negative 2. So again, be careful about what is the minimum versus where is the minimum. What about the absolute maximum? Good. You're like, no. Something's at 5, but the thing at 5 is a whole. So this is that picture that we were... Actually, the picture is pretty close to something like... Well, no, the left end is fine. The right end, there's a hole at 0, 5. So there is no max. Because there's a hole there. Alright, so those endpoints are tricky, especially if they're not included. Alright, I picked that one to work. What do you want to see? I feel pretty good about 4 and 5. I'm happy to work them if you want. Or we could work some from the other worksheet.
Can you see on the graph of the first problem?
Yep. So looking at that graph of f prime, let g be the function defined by x times f of x. Find an equation for the tangent line to the graph of g at x equals 2. Tangent line, I need a point and I need a slope. Well, the point is going to be 2 comma g of 2. So I'll need to figure out what g of 2 is. And the slope would be the derivative of g at 2. So I need to find g of 2 for the point and g prime of 2 for the slope. So g of 2 would be, again, just looking at what they told me g is, 2 times f of 2. F of 2. I hope they gave me f of 2 somewhere, because that graph is not f, that graph is f prime. Did they give me f of 2? Yeah, that very last statement. And when you first read the question, it's like f of 2 equals 6. Why do I need that? Well, I need it down here. F of 2 is 6. So g of 2 is 12. So I got my point. 2 comma 12. Now I need the slope. So I need g prime. How am I going to take a derivative of x times f of x? What rule will that be? Product rule. So I'm really short on space, so I'm going to go product rule in place here. The first one is x times derivative of the second one plus the second one times the derivative of the first one. So a product rule. Pretty simple product rule, but still a product rule. So g prime of 2 times f prime of 2, which I can probably get from the graph, plus f of 2, which we already said was 6. So f prime of 2 I can get from the graph. What's f prime at 2? Negative 1. Again, I just read that off the graph. The graph is f prime. So at 2, negative 1, that means f prime of 2 is negative 1. The slope of f at 2 is negative 1. So 2 times negative 1 plus 6 would be 4. So that's the slope of g at 2 is 4. So now I've got all the pieces I need. Y minus 12 equals 4 times x minus 2. It's a great example of an AP type question. Something that we've never seen before, but something that we are capable of doing because we know how to use product rule and graphs. And man, they pieced a lot of stuff together in that one question.
Can you also go for B? I don't understand like the absolute max.
Okay. At what value of x does f obtain its absolute minimum value on the closed interval -1 to 5? Okay. Well, between -1 and 5, there's only one point that's a relative extrema, and it's at 4. Let's see, if f prime changes from negative to positive, then that's a relative minimum. Well, I should say f has a relative minimum at x equals 4. So if I mean, who knows what this graph looks like, but the only minimum it has is at 4. So whatever else is going on, that's the only relative minimum it has. That means it's got to be the absolute minimum. Right? Another way to say it is if it's decreasing in front of 4 and increasing after 4, there's no way for any points to be lower than 4. So 4's got to be the absolute minimum. At what value of x does it obtain its absolute maximum? Show the analysis that leads to your answer. Well, there's no relative maximums. So the absolute max has to be an endpoint. So that narrows it down to either -1 or to 5. So we look at our graph, and f is decreasing from -1 to 4. And f is increasing, f, not f prime, from 4 to 5. So we increase from 4 to 5, we decrease from -1 to 4. So what do you think we did more of? Did we do more decreasing or more increasing? Let's see, how do we say this? We decreased, f decreased from -1 to 4. That's a much wider span than just 4 to 5. So there was more decreasing going on. So I think we can say the absolute max happens at x equals -1. Because we did a whole lot more decreasing than we did increasing. That's probably the trickiest question of that set. How do you explain that? And again, it's just about all of this is f decreasing. F increasing is all of that. Well, we didn't increase very much. So we decreased for a lot, and then we increased for a little. So the max would have been over here at the start of that big decrease. That's a tricky one. Other questions from this multiple choice practice? There will be. I will post a key because I found one. I just haven't. Yeah, if it's not posted yet, it will be. Especially since I have it right here. What else? Other questions from? 7, 8, 9. Some of those are
Can you do 7?
number 7. For what value of k will x plus k over x have a relative maximum at x equals -2? I'm going to rewrite that so I can take its derivative. Let's see, a relative maximum would mean f prime equals 0. But that wouldn't be enough, right? That means that would have to be true, but that alone wouldn't be enough. Then I could either do the first derivative test and say f prime changes positive to negative. Or I could do a second derivative test and say that the second derivative at -2, would that have to be concave up or concave down? If there's a maximum, it'd be concave down. So that would need to be, second derivative would need to be positive. So I'm not sure about these, but at least f prime has to be 0. So let's find f prime. 1 minus k x to the -2, because the -1 came down. So 1 minus k over x squared equals 0. But x is -2, so I can plug -2 in for x. So 1 minus k over 4 equals 0. So k would have to be, again, you could do some algebra on that, or hopefully you could just look at it and say, well, this fraction would need to be 1, so k would need to be 4. So for what value of k? So we're looking for k. So k equals 4 is a pretty strong contender for an answer, although I haven't yet shown that that's a maximum. So none of these is still in play here, so I better be careful. I need to check the second derivative. So that would be negative would be positive 2k x to the -3. So k is 4. X to the -3, but x is -2. So my second derivative then is -1. What does that mean if the second derivative is negative? It's concave down. And it was a horizontal tangent line. So yes, we have a max when k is 4. Eight or 9? I don't think 10's that hard, but 8 and 9 both have some tricks in them. Number 9. If f double prime equals that, which is ugly, but that is the second derivative, so inflection points, that would be where f double prime changes signs. So in some ways this is great news, right? They gave me the second derivative, so I don't have to find a derivative. They gave me the second derivative. So those second derivative critical points, remember that's not exactly what they're called, but something's going on at 0, -1, and 2. Now, officially I should check all of those spots and see what's happening, but I think there's a better way to know when it changes, because what's going on at 2? What does this mean? That's that double root thing. So it's not going to alternate at 2. It's not going to change at 2. So at 2, there's not going to be a point of inflection. I don't know who's positive and who's negative here, but at 2, it's going to be the same thing. So there will be a change at -1 and 0, but not at 2. Now, I could spend some more time and get into the details of that, but I can tell already there's not going to be a change at 2. And there will be at -1 and 0. Okay, well let's plug in 3. So if we plug in 3, we get into f double prime. So I get 3 times 4 times 3 minus 1, 3 minus 2 squared, but all that's positive. If I plug in 1, I get 1 times 2 times -1 squared. When I square the -1, it goes positive, everything's positive.
So you just like randomly plugged it in.
I didn't plug it in. I know that if there's a double root, that's like a bounce,
Um,
right, as opposed to a cross. So I knew that something strange was going on at 2. Now I could plug in the others, but I also know the shortcut, so that's going to be minus, that's going to be plus. So there'll be a point of inflection when f double prime changes signs at -1 and 0, but not at 2, not a poi. Something similar happens on number 10. You do the number line and you end up with increasing, decreasing. And so the maximum value would be whatever that spot is. That's sort of jumping in halfway into the problem. Emily?
How do you do that derivative? Because I could not.
So it might help to rewrite that as 1/3 x to the 4th minus 1/5 x to the 5th, if that helps. So 4/3 x cubed minus x to the 4th. Oh, wait a minute. Let's be super careful on this. You got to read. The derivative of f attains its maximum value. So there's f prime, but I want to know where that maxes out. So you know what? Let's just rewrite that. The derivative of f is this. So if I want to maximize this, what do I need to do? What do we do if we want to maximize a function?
Double.
Take its derivative. So I need to take the derivative of this guy. The prime. And now I see why those weird fractions were in there, because that works out to be kind of nice in terms of setting it equal to 0. So 0 and 1 are our critical points of the first derivative. I'll phrase it that way.
What homework is due? Or do we turn everything in?
So I think 3 of the 4 are going to be due. You've had page 192. You had a worksheet that was like Calculus X. Something like that was the title. And then you had this worksheet that we're working on right now. And then you had a review. And so 3 of the 4 are due. And I'll make sure answers to this one are posted.